So in the last section we graphed quadratic functions in standard form. Section 4.2 is graphing quadratic functions in vertex form and intercept form. So vertex form should look familiar to you. Its form is similar to absolute value that we used in section 2.8. It's of the form y equals a times x minus h squared plus k. And so this should look familiar to when we had absolute value form. And in the same way, our vertex is going to be hk. So in other words, if I take the x minus h and set it equal to 0, I'm going to get h. And if I went through the work of plugging that h back in, h minus h is 0, times squared is 0 times a, and so that's why I get that the y is k. Again, the axis of symmetry is that vertical line, x equals h. And again, still, the graph will open up if a is greater than 0, and it will open down if a is less than 0. So again, this is still similar to that absolute value form in section 2.8. So now let's go ahead and graph one. We have y equals 1/2 x plus 3 squared minus 5. So our vertex is -3, -5. And again, to reminder that the way we get that -3 is by taking what's in the parentheses and set it equal to 0. So we get x equals -3. So we're going to plot that point. And then our axis of symmetry, of course, goes down through the vertex. So that's going to be x equals -3. And we're going to plot that line, or graph a sketch of that line. And then remember, we can pick either 2 points to the right or 3 points, to the left of the axis of symmetry. And I'm just going to pick -2, -1, and 0. And when you plug those into the function, you'll get -4.5, -3, and -1/2. So then we're going to go ahead and plot those points. And then, of course, using that axis of symmetry, just like we did with standard form, we're going to plot those reflections on the other side to get the other half of the parabola. And once we've got all 7 points graphed, we can draw our line through it, and we have a parabola. And so just to recap, the work I want to see, it's not necessarily really work, but I want you to tell me what the vertex is. I want you to name what the axis of symmetry is. And then you need to show me your t-chart. And, of course, a proper graph. And so then with every kind of problem, we have to have a corresponding word problem to make this be a realistic problem, or at least applicable problem. So the Tacoma Narrows Bridge in Washington has 2 towers that rise 307 feet above the road and are connected by suspension cables, and there's a picture. Each cable forms a parabola with the following equation, where x and y are measured in feet. And so if we notice, this is in vertex form. And so let's just identify from our equation what our vertex is. It's 1427. And so what does that mean? Well, that kind of makes it that the x and y axes are going to have to be one of the towers and the road. And so if we look at where the vertex is, what exactly does that mean? Well, that means it's 1400 feet from the origin, which basically is halfway across. So if we go another 1400 feet to the other side, because the vertex has to be in the middle, we're going to get that it is 2800. And we're told that x and y are measured in feet, so it's 2800 feet between the 2 towers. So the second part, what is the height h above the road of the cable at its lowest point? Well, again, where is that lowest point? The lowest point's at the vertex. And specifically, it's the y-coordinate of the vertex. So again, since x and y are both measured in feet, the y-coordinate of the vertex is 27. So it's 27 feet above the road. So realize that a lot of times these word problems don't necessarily take a lot of calculations in math. It takes a little bit of looking at the equation and understanding what that equation means. And sometimes it's easier, if you're not provided with a picture, to draw a picture. And really the only math we did was multiplying 1400 times 2. So these word problems aren't always really difficult. Alright, so now let's go on to intercept form. So now let's think about the name intercept form. It's got to have an intercepts, either x-intercepts, so it crosses the x-axis, or the y-intercepts, where it crosses the y-axis. Well, it's y equals, and it's going to be x that's in the parentheses with the numbers, so those are indeed our x-intercepts. And if we take those values and set them equal to 0, that's how we get our p and our q. So if I take x minus p, set it equal to 0, I get x equals p, and the same with the q. And keep in mind that those are ordered pairs. That's where it crosses the x-axis, so my y-coordinate obviously is going to be 0. The vertex and the axis of symmetry is halfway between p and q. Well, how do you find halfway between 2 points? The x-coordinate is you're going to take the average, so add p and q and divide by 2. And then the same as with standard form, to find the y-coordinate, you're going to plug in that x value into the original equation, and that's going to tell you the y-coordinate of the vertex. And again, your axis of symmetry is simply going to be that line x equals whatever your x-coordinate is. And the same as with the other two forms, the graph opens up if a is greater than 0, and down if a is less than 0. Alright, so now let's go ahead and graph one intercept form. So first of all, this might not look like intercept form, but keep in mind that intercept form is the only form that doesn't have an exponent in it. Both vertex and standard form have an exponent in it. So we could rewrite this as -1 for our a, and then x minus 0 and x minus 4. So the first thing still to find is going to be the vertex. So to find the x-coordinate of the vertex, we take our p and our q, so 0 plus 4, and divide it by 2, and we get 2. And then to find our y-coordinate, we're going to plug that back into our original equation, and we're going to get 4. So we go ahead and plot our vertex. And then, of course, we've got to name what our axis of symmetry is, and still that's the vertical line that goes down through the vertex, so x equals 2, and we're going to graph that. And then finally we make our t-chart, and again picking either 3 points to the left or 3 points to the right. And so I picked 1, 0, and -1. When I plug those into the original equation, I get 3, 0, and -5. And then once again plotting those 3 ordered pairs, and of course the reflections across the axis of symmetry. Sketch in your parabola, and we're done. And again, just to recap, you need to make sure that you're showing me the vertex and the work for at least the x-coordinate of the vertex. Show me the axis of symmetry. Again, don't forget that it's x equals a number. And then the t-chart. And finally, of course, is the graph. And of course, with any good problem, new kind of problem to do, there's a corresponding word problem. So if an object is propelled straight upward from Earth at an initial velocity of 80 feet per second, its height after t seconds is given by this following function. And keeping in mind that t is the time in seconds after it is propelled, and h is the object's height in feet. So how many seconds after it is propelled will the object hit the ground? Well, let's think about this for a second. T is the time in seconds, and this is in intercept form because, again, there's no exponent. And so I see that my a is negative, which means that my parabola is going to open down. And so my intercepts, if I were to rewrite this again as t minus 0 and t minus 5, my intercepts would be 0 and 5. And so since my x-axis is now my time, or t-axis, t being 0 is going to be at the origin. And then the 5 is obviously going to be 5 seconds later. So if we look at this picture that actually shows what's happening, an object is being propelled upward in the air and then it comes down. So it's going to hit the y-axis when y is 0 after 5 seconds. So again, it's a matter of being able to interpret the equation. So what is the maximum height? Well, again, we have this same picture, and keep in mind the maximum height is going to be at the vertex. But it's the y-coordinate of the vertex. That's the h of t. That's the height. So first we have to find our time at the vertex. So 0 plus 5 divided by 2 is 2.5. And it's time in seconds, so this means 2.5 seconds. Now if we take that and plug it back in, we're going to find the height at 2.5 seconds. and we just plug that into the original equation and simplify that, and we get 100. So my vertex is 2.5 100. And so again, it's a matter of being able to use this information and interpret what that means. And that means at 2.5 seconds, it reaches a maximum height of 100 feet, according to these labels. And the last thing we have to do is basically changing functions into standard form. And this is hopefully a refresher in just basically algebraic manipulation. So the first thing we're going to do, we're going to keep the y equals 3, and we're going to multiply these two binomials together. And you might have been introduced to this as foiling. So we're going to take the x times the x. We have to multiply everything in the first equation, parentheses, times everything in the second parentheses. So x times x gives us x squared. And then the x times the 6 is 6x. And then the 4. So negative 4 times x is negative 4x. And negative 4 times 6 is negative 24. And so now it's probably going to be easiest if we combine our like terms and make that 2x. And then of course we need to distribute the 3. So when we do that, we get y equals 3x squared plus 6x minus 72. And this is in standard form. And just a reminder that if you were to find the vertex the way you know how to in intercept form, and you were to find the vertex the way you know how to in standard form, if you do your math right, you should come up with the same vertex, because these are two forms of the same equation. So now let's move on vertex to standard form. So again, we need to remember that this x plus 8 quantity squared is actually x plus 8 times x plus 8. And then don't forget the plus 35. So the order of operations, we have to take care of the multiplication before we can do the addition. And again, I'm going to leave that negative 1/2 alone, and I'm going to multiply the x times the x, and the x times the 8 times the x, and the 8 times the 8. Don't forget the plus 35. Again, I'm just going to simplify things by combining like terms. Again, don't forget that plus 35, and I keep saying that because that is what tends to happen, is that 35 gets dropped somewhere along the way. But next, before we can add anything, we still need to distribute that negative 1/2. And so when we do, we can't forget the plus 35, and then finally we can add that. And when we do, we get negative 1/2 x squared minus 8 plus 3. And again, the vertex in this is negative 835, right? Because this is vertex form. And if you were to find the vertex the way you know how to do, negative b over 2a, then you would also, and then plug that in, you should also get the 35. All right, so don't forget to go back and do the notes check, and we'll see you tomorrow in class. Make sure you come with your questions.